Hello everyone, thanks for being here for today's presentation. My name is Hanumanth Thopuri. Today I'll be taking about deep learning and large language models for natural language processing, commonly known as NLP. So over the next 15 minutes we'll explore how the combination of deep learning and large language models has completely reshaped the way machines understand and generate human language. We'll start by looking at what NLP actually is, then trace its evolution from traditional rules-based systems to deep learning architectures like RNN, CNN, and transformers. After that, we'll move into the real-world applications, challenges, and the future directions of this fast-moving field. By the end, I hope you'll have a clear sense of why NLP is one of the most transformative areas in artificial intelligence today. We'll move to introduction of NLP. NLP stands for Natural Language Processing, the branch of AI that focuses on enabling computers to understand, interpret, and communicate in human language. For decades, NLP was largely rule-based. Experts wrote handcrafted grammar rules and patterns. For example, if a word ends with ed, it might be past tense verb. These systems worked for simple tasks, but it couldn't handle ambiguity or context. For instance, the word bank could mean be a river or bank or financial institution, depending on the context. So then came the statistical NLP, where we used probabilities and counts from large text corpora to predict meaning. This helps somewhat, but still we required a lot of manual feature engineering, deciding which aspects of context were more important for a model to learn. So the real revolution came with deep learning. Instead of human designing rules, we now train neural networks that automatically learn the patterns and structure of language from massive data sets. That leads to model that can summarize books, answer questions, and even hold human-like conversations. We'll move to the evolution of deep learning in NLP. To understand how we got there, let's briefly trace the evolution of deep learning in natural language processing. Around 2013, models like What2VC and GLOW introduced word embeddings, dense numerical representations that captured the meaning and relationship between words. Next came recurrent neural networks or RNS. They processed text sequentially word by word, maintaining a memory of past information. But RNN had a big limitation. They struggled with the long sentences because early context was forgotten. To fix this, long short-term memory networks, it's called LSTMs, were introduced. They could remember information over long tasks like speech recognition and text generation. Then, conventional neural networks called as CNNs, known for computer vision, found use in text classification, detecting key phrases and sentiment patterns. All of this led up to the transformer revolution, which replaced recurrence with attention in mechanisms, allowing models to consider all words in a sentence simultaneously. We'll move how deep learning in NLP and how it works. So, at their core, these models work by learning representations, mathematical encodings of meaning. Let's talk. Let's take a sentence. The cat sat on the mat. Each word is converted into a vector, a list of numbers that represented its meanings. These vectors are then passed through neural layers that capture increasingly complex relationships, syntax, semantics, and context. Here, different neural architectures handle these representations differently. We talked before CNN, RNN, and LSTMs. Here, the new one comes sequence to sequence models. For example, converting Bonjour le monde. And it will convert into English. Hello world. So these models learn breakthrough backpropagations, adjusting millions of parameters to minimize prediction errors, gradually understanding how words interact. We'll see how the transformer architecture. In 2017, researchers at Google introduced the paper Attention is All You Need, and it truly lived up at the name. The transformer architecture removed recurrence altogether and introduced self-attention. Instead of processing words one at a time, self-attention allows the model to look at every word in a sentence simultaneously, and it decides which words are most relevant to each other. For an instance, in a sentence, the animal didn't cross the street because it was too tired. So the model must realize that it refers to the animal, not the street. Self-attention makes this kind of reasoning possible. So transformers are also enable parallel computation, which drastically speeds up training and making it possible to scale enormous datasets. The design became the backbone for nearly every modern NLP model from BERT to GPT to T5, and will move popular transformer models. Since 2017, a wave of transformer-based models has taken to NLP new heights, but bidirectional encoder representations from transformers. It means which it learns context from both left to right and perfect for understanding meaning in context. GPT, Generative Pre-trained Transformer, which it focuses on generating human-like text. It's what power models like ChatGPT, whereas T5, text-to-text transfer transformer, treats every NLP task as converting one piece of text to another, a very elegant unification. And the next one, the robot term, XLNet and PAM and LLAME. So further pushed accuracy and efficiency. These models are trained on massive datasets, often hundreds of billions of words, and fine-tuned for specific tasks like summarization, questioning, answering, and code generation. We'll see the applications of deep learning and LLMs in NLP. Now, let's see how these models are applied in the real world. Sentiment and emotion analysis. Companies analyze tweets, reviews, or comments to understand public opinion. Machine translation. Tools like Google Translate rely on deep learning to produce context-aware translations across languages. Summarization. New apps and research tools use models to automatically summarize long documents into key points. Question answering. Think of systems like Siri, Alexa, or search engines that can respond directly to your questions. Conversational AI and chatbots. From customer service bots to personal assistants, NLP enables natural conversations. And text generation, creative writing tools, email composition assistants, and code completion system are powered by LLMs. In short, these technologies are embedded in our daily lives even when we notice them. We'll move to the challenges in deep learning and LLMs for NLP. With all these successes, we must also acknowledge the challenges. First, bias. If models are trained on biased data, for example, associating certain professions with a gender, they can reproduce or even amplify those biases. Second one, hallucination. LLMs sometimes generate text that sounds right, but it's actually wrong. A major concern for tasks requiring accuracy. Third, explainability. Deep learning models are often black boxes. We don't always know why they give certain outputs. Finally, ethics and privacy. Using sensitive or copyrighted data for training raises important questions about consent and misuse. Addressing these issues will be crucial to building responsible and transparent NLP systems in the future. We'll see what are the limitations of deep learning and LLMs. Even with their power, these models have limitations. They are extremely data hungry, needing billions of examples and energy intensive to train, which it has environmental costs. They can also be fragile. It's called a small change in input wording which it can leads to completely different results. Perhaps most importantly, they don't truly understand language in human sense. They just predict the next word based on probability, not real comprehension. So, while they stimulate understanding very well, there's still a long way to go before where we achieve true reasoning or common sense in the NLP systems. So by predicting this, we'll see how the next word based on probability or on based on the comprehension. We'll see the future directions. The future of NLP is very exciting. We are moving towards efficient models that can perform well with their fewer parameters and less data, using methods like distillation and quantization. We'll see growth in multimodal AI, where text interacts with vision and sound, like image captioning or video understanding. There also research in reason-based models, combining symbolic AI and neural networks to improve logic and explainability. Most importantly, responsible AI will be the guiding principle, ensuring fairness, reducing bias, and building systems aligned with the human values. Now, we'll walk through the real world impacts and case studies of NLP. NLP is already having huge real world impact. In healthcare, NLP helps doctors to summarize the patient records, identify potential diagnosis, whereas in finance, it's used to detect fraud, automate complaints check, and even analyze market sentiment from news and social media. In education, personalized tutoring systems and write assistants help students to improve their communication skills. For example, it also helps to learn or to build any models or any language to convert from one language to one language. For example, we'll see aqua. It translates into in English, it's called water. So this is how NLP helps. Even in law and government, NLP tools assist with document review, case summarization, and policy analysis. So NLP isn't just a research topic, it's a foundational technology which is driving through the digital transformation of nearly every industry. Finally, we'll move to the conclusion. To conclude, deep learning has completely revolutionized NLP, transforming it from rigid, rule-based systems into adaptive, context-driven intelligence. Whereas the large language models like BERT, GPT, and T5 represent the current frontier capable of understanding, generating, and reasoning with the text in ways we couldn't even imagine in just few years ago. But as we continue to build bigger and more capable models, it's equally important to make them ethical, explainable, and efficient. The future of NLP lies in human AI collaboration, where machines and enhance our ability to communicate, learn, and create responsibility. Thanks for listening.